Hi, welcome back. This is part two of our video on my work in probability theory that spawned from studying the lottery Mega Millions. And we're looking at 70 pick 5 and our ideal geometric distribution of 11.5, 23.5, 35.5, 47.5, and 59.5. Call these S1, S2, S3, S4, and S5. And in this equation, to be in the first geometric class, which is the closest that you can be to the standard and the smallest, which also gives the smallest divergent sum value, or DS value, that you can have is 2.5. Why is it 2.5? Because the closest that you can be to S1 through S5 in picking 5 balls is on either side of each one of the standards. And since the standards are at a 0.5 off in between each one of their respective positions, you get a 0.5 plus 0.5 plus 0.5 plus 0.5 plus 0.5, which gives you 2.5. And that's the smallest DS value that you can have. And well, again, it's the first geometric class. We are interested in defining and categorizing lottery numbers, the 12,103,014 possible combinations for 70 pick 5 without replacement, it are subjugated into geometric categories whenever you measure them against the standard. And this equation here has 32 solutions by so if you just look, it's 2 times 2 4 8 16 32. It's pretty straightforward. We're not going to spend a lot of time explaining like the logic of why it's 32. We have more important things to talk about here. If you need more convincing, just go back and look at it yourself. I can't explain everything. I keep running out of time whenever I go in like details, and I've tried doing this video before, and now it's like an hour and a half long, and I still wasn't happy with it. So now I'm just trying to condense it into the first 15 minutes that we did, and however long this second video ends up being, probably another 15 minutes. But but this is going to be it. And again, like I said in the first video, this is a work in progress, and I'm trying very hard to get you up to speed of where I am now and what I am currently attempting to do, which is count the number of combinations in each geometric class. Because if you'll recall from the first video, if you sum the possible combinations for every category, yes, if you sum the possible combinations for each geometric class, then you get the raw total number of possibilities. Remember, yeah, again, like too much detail takes up too much time. And there goes my timer glitched out again. Ah, so annoying. Okay, let me just keep moving forward. Okay, so second geometric class has a value of 3.5, and you'll note that we expand the possible location, position, or picking point, however you want to say it, for each one of the balls off of each standard, and it is one off on just one of them. The other 4 have to be on. And in allowing just one pick to be one off, in other words, like for just one of these, you would be at like if it was if you were at S1 and you wanted to be one off, you would either be at 10 or you would be at 13. All the other ones, the remaining four standard points would be either 23 or 24, not 22 or 25, be 35 or 36, not 34 or 37, etc. And so these purple dots signify the one that is one off, and there are 160 possible combinations. Moving on, this is where it gets more like mathematical, and you have to, because there's going to be eventually thousands and thousands of combinations. Because if you remember looking at this, like, see how there's a regular increase in class sizes up to the largest class, the 23rd class. This was for 70 pick 2. And I hope to be able to extrapolate the size of the largest geometric class without having to calculate it directly in this way, but I might have to do that anyway. We're just going to have to see. But for 70 pick 2, there's a regular geometric progression, and if you were just calculating first class is 4, second class is 8, third class is 12, fourth class is 16, 17, 18, 19, 20. What do you think the next class is going to be? So it's increasing by 4 each time. So that's a regular geometric progression. But for 70 pick 5, it's uh, not as straightforward. But so we had 32 and then 160. And then in the third geometric class, the way that we calculate it is, well, I also want you to realize that whenever we expand a possibility of being one off on either side of the standard, but it's just one of them, for the um, for the third geometric class, you can have one being two off or two being one off, and uh, I guess just with expanding one off on either side, you're able to get up to elements of the sixth geometric class. So there's not a one-to-one correspondence with increasing the class size and what geometric class you will have allowed for it. So just with increasing one possibility off on either side from being on to being able to be one off on either side, you're hitting elements in these 1, 2, 3, 4, 5, and 6 geometric classes. So, but for the third geometric class, it's 1 being 2 off or 2 being 1 off. And that's a partition of 2. And you get 480 possibilities. For 2 off, it's the same as 160 because you're just calculating, instead of 1 being 1 off, you have 1 being 2 off, and it doesn't matter how far away off it is for the number of possibilities that you can have whenever it's like that. 1 off, or 1 something off. Fourth geometric class is 1 being 3 off, as we say, and that is signified by the partitions of 3. So you can have 1 being 3 off, you can have 1 being 2 off, and 1 being 1 off, or you can have 3 being 1 off. And whenever you calculate it, you add up the possibilities, you get 800. And I haven't even made it yet I just have notes on the, let's see, fourth geometric class is the partitions of 3. The fifth geometric class will be the partitions of 4. It has 1,280 possibilities, I calculated. And then the sixth geometric class is calculated with the partitions of 5 and has 1,632 possibilities. And so we just want to continue on with this process Okay, so that's like coming at it from the bottom up. We also tried to tackle, this is what we had tried to do before. Now we're trying to work our way up to it and trying to see if there's a pattern that'll tell us how big the largest class is going to be. But we know what the largest class is. We just don't know how big it is. But we can also get a an estimation on how big the average class size is by taking 12,103,014 divided by the total number of geometric classes for 70pic5, which is 160. I don't know what I just did there. 12,103,014 divided by 160. Okay, so the average class size needs to be, it is 75,643 some odd change. So these classes are going to get big pretty fast, and uh, yeah, we want to know how big all the classes are, and it's going to end up looking something like this, but not exactly like it. And this is actually a earlier version. That's wrong. Like that should be here. Don't worry about it. It's a very minor detail. I already solved it. Like it was just it's nothing. But this is like the main picture, what it's going to look like, and notice it's an off-center distribution, and we had thought that it might be the case that yeah, that there was going to be like a secondary hump in 70pic5, but that just remains to be seen. We don't know that yet, but it looks that way from analyzing genuine lottery numbers. Like I don't see it right now, but I picked 50 lottery numbers and analyzed them against the ideal geometric standard, and I got a picture that looked similar to this with the secondary hump there. But and then I just started looking at on the internet for articles about random distribution and probability and whatnot, and I came up with this article in Medium. It's called "There Is No Randomness, Only Chaos and Complexity," and it's basically an article about how uh, you don't have true randomness in nature because true randomness is a theoretical limit, and how entanglement and uh, and recursion, entanglement and recursion are sufficient to produce all of this emergent complexity that we see in nature. And uh, in terms of the skewed distribution of possibilities, the skew in the direction of the uh, the entanglement, in our case, the standard. See, everything is like being drawn towards the standard so that you have more possibilities closer to the standard and fewer possibilities farther away, just in a very general sense. And uh, because again, we know already that um, the number of possibilities in the largest geometric class, excuse me, in the high, like I guess we'll say the last geometric class, the 160th in the case of 70pic5. In the case of 70pic2, it is the 68th class. Whether it's the highest class in 70pic2 or in 70pic5, they both only have two members in them. They are the ones where you pick the first two or the last two of 70. Pick 1 and 2, or pick 68 and 69. If it's 70pic5, then you pick the first 5 balls or the last 5 balls. And remember, the standard is symmetrical across the middle, so you get the same number and you get 162.5, because remember, the first geometric class has a value of 2.5, So anything that you have is going to